Alright, so this one you have sine over cosecant plus cosine over secant. Well, normally you would sit there and think you had common denominators, but I noticed right away that these guys are reciprocals. Okay? So if I rewrite this, that's sine over 1 times 1 over cosecant, which is sine times sine, which is sine squared. Cosine secant, same pattern, different letters. You get sine squared then plus cosine squared, otherwise known as 1. Exactly. Yeah, like I said yesterday, none of this works unless those values of x's or thetas or anything are the same. It just so happens that that's 50, the one below it's 350. The properties still hold true. It has to. Okay. So let's see, where are we at? 10. 10, you wind up with cosecant squared minus cotangent squared. Cosecant squared minus cotangent squared is 1. Next one is you bring the cosine up, you get secant squared minus 1, which is tangent squared. Bless you. Bless you. Thought you were late for no. 12. Again, bring that cosine up, you get secant squared. Then you have secant times cosine happens to also be 1, so you have another secant squared minus 1, which is tangent squared. 13 is the style that you'd split into two fractions. I mean, I know that 1 plus tangent squared is secant squared, but I also see this real quick that I can do 1 over tangent squared plus tangent squared over tangent squared. I get cotangent squared plus 1, which is cosecant squared. The next one you wind up with, you've got the 1 plus tangent squared in the numerator and cotangent squared plus 1 in the denominator. So you wind up with secant squared over cosecant squared. So 1 plus tangent squared over 1 plus cotangent squared. So you get secant squared over cosecant squared. Those two guys are reciprocal functions, aren't they? Yeah. So if I flip either one of, so let me say this here. So this is secant squared times 1 over, I always make my s's backwards when I do this, cosecant squared. Just split it apart. You okay with that? So secant squared is 1 over cosine. 1 over cosecant squared is sine squared. So you wind up with sine squared over cosine squared, which is one giant puzzle. That cosine squared of 50 plus sine squared of 50 is?
From what side?
1. And then 1 plus tangent squared we just did. That's secant squared. Cosecant squared minus cotangent squared is 1. Secant squared minus tangent squared is also 1. Okay, those just go over on the battery. Verify. Hi. 1 plus tangent squared is secant squared. Did I say 1? 17 was 1, because 17 you have cosecant squared minus cotangent squared. That's where you get the 1. Okay. Verifies. So sine squared times 1 plus cosine squared. Oh, cotangent squared, excuse me. I looked at the wrong one. Well, you could distribute, or what's 1 plus cotangent squared? Cosecant squared. When you multiply a number by its reciprocal, you always get 1. So when you multiply sine squared by its reciprocal, you get 1. (32) is very similar to that. You have sine squared, you have cosecant squared plus secant squared. We want to make sure that this equals secant squared. So in this case, you're going to want to do your distributive property. You wind up with sine squared times, sine squared cosecant squared plus sine squared secant squared. Well, sine times cosecant is always going to be 1. So sine squared times cosecant squared is also 1. All right. Secant is the reciprocal of cosine. So secant squared is 1 over cosine squared. So you get 1 plus sine squared cosine squared, which is 1 plus tangent squared, otherwise known as
secant squared.
33 and 34 are very, very, very similar to one another. Yes, ma'am. No, you're fine. Yeah, there's nothing wrong with what you did there. Absolutely nothing wrong with what you did there. It's just you went and going sines and cosines, which is fine. I knew that. I recognized. I knew that's going to be 1 instead of writing a sine squared or sine squared. I knew that's 1, and this one I knew was going to go to cosine. We got the tangent. You're going to get the same result. Yeah, guys. Sir's got a good question here. Remember, there's more than one way to go about setting these things through. You're going to get there if you're on the right track. Okay. There's not one method is better than another. You might have seen something a little bit differently than I have. It's not to say that you're wrong. No, I'm kidding. It's just one of those things. You might see it a different way. Okay? So like I said, 33 and 34 are very similar. Notice in 33, you have cosine squared minus a sine squared, and you wind up with 2 sine squareds. Well, that means you have to rewrite cosine in terms of sine, or cosine squared in terms of sines. Cosine squared is 1 minus sine squared. How many negative sine squares do I have? Remember that problem I wrote out yesterday, Katie? The one I wrote on the board with the solving the equations? This is the trick that you'll use a lot when we do equation stuff. Rewriting sines and cosines in terms of the other. It happens a lot. Okay. Bless you. What's that? I'm sorry? What's it? Right, and this is what's getting used to it. Okay. Same deal with the other one. You have, was it cosine squared minus sine squared, and you want it to be 2 cosine squared, and a minus 1 at the end. So now you have to rewrite sine squared in terms of cosine. And this is where most of you guys will screw up. You get cosine squared minus the quantity 1 minus cosine squared. You have to distribute the negative. You get minus 1, then you have a plus cosine squared. Which gives you 2 cosine squared minus 1. I am. Thank you for calling me a musical genius. But it was very sad musical afternoon or early evening last night for me. Pearl Jam postponed their spring tour.
Oh no!
They're from Seattle, and the letter they posted out to people, they have all their families, everybody's been quarantined, everybody's been shut down, the whole thing's shut through. They're traveling to mainly the East Coast to begin the tour. It's supposed to start next week. So East Coast, where Baltimore, New York, all those big cities where it's just a poop show, shall we say, and think of it and with a word that you can reword words, letters this for it. Huh? Yeah, so it's a bit of a disaster. So I found out late last night After Conrad had gone to bed, so I haven't told him yet. So,
Oh, you got a ticket. Yeah.
but they're still gonna go. They're still gonna. It's just gonna be. Yeah, I'll be like because this summer they're touring Europe in the summer, and most of their Europe shows are outside the stadiums, and they feel that stadiums are better than arenas with roofs. Whatever, I get it. I totally understand it. Plus the demographics for people who go to that show are a little bit on the older side, like me. I guess we're susceptible. Well, not me. I'm not that old.
Really?
I saw that. What?
I know she did. Because I'm probably older. I'm older than her. No, your dad's older than me. Not by much. What's that?
You know the ID dragons, right? You just have to show it.
What?
35. So 35, 36. Those guys are the trick I was showing you guys yesterday. When you go from addition to multiplication, usually what happens is you wind up with common denominators. So if you're looking at 35 and 36, they're both kind of the same thing. You have cotangent plus tangent, and you want it to equal cosecant, secant. Well, what I would always do, I would rewrite in terms of sines and cosines. So cotangent is cosine over sine. And then over sine over cosine. The common denominator here becomes sine times cosine. Fraction on the left needs a cosine, so you get cosine squared. Fraction on the right needs a sine, so you get sine squared, which therefore gives you 1 over sine cosine, which is cosecant secant. Cosine squared plus sine squared? 36 is very similar. Secant squared, cosecant squared. You want it to equal secant squared times cosecant squared. Okay. Again, same idea. Rewrite it as sines and cosines.
There's a plus.
What's the common denominator going to be? See how this falls real quick now?
Yeah.
You have cosine sine squared. Needs a sine squared. Needs a cosine squared. Which gives you 1 over. Which therefore is Did anybody get 37?
No, I didn't try.
You babies. Yeah, where? I don't know my son.
That one is 38.
Oh, you know what, Rick? I totally forgot to think about a song from Ace of Base. No, I forgot. I can't name one.
Yeah. You could just
Yeah, and I would have felt bad taking money from it. And then somebody would yell at me for not buying a cookie dough. That's
There we go, here we go.
All right, so let me ask you this. You're gonna hate me for this one. Is that a perfect square? Is that a perfect square? It's a different square. It's a different squares. You get cosine squared minus sine squared. And what's the other term? Cosine squared plus sine squared. No, why would that back down? What's cosine squared plus sine squared? 1, and you're done.
Whoa. Okay. That's so dumb.
I love it. You guys can still fit.
Wait, is that better?
Cosine squared plus sine squared is 1.
So the one is
Supposed to be.
Uh-huh. Alright. So this one's kind of gross. Did anybody try to see what you would get?
No.
What'd you do first? You got 2? Oh.
I put parentheses on the cosine tangent and then on sine tangent.
And then you factored out the tangent?
Yeah.
I like that idea. Oh, let's see what, I like that. Everybody hear what she said?
Yeah.
Sarah said she tried this. Isn't that okay to do?
Yeah.
I put like 2 sets of parentheses.
Oh, see, I was going to do this. Because what do these two terms have in common?
Oh, and then so it's tangent squared plus 2.
No.
No.
What's in the parentheses?
Oh my gosh. We're not bad at
Yeah, that's very common. Yes, ma'am. Which one? 4? So back to number 4, cosine over cotangent. So when I see this, I want to rewrite this as cosine over 1 times 1 over cotangent, just to split the fraction. Then I'll rewrite it one more time. And then I go to sines and cosines. You can skip a couple of steps here and there. I like, especially the first few days, I try to write out as much as I can so you guys start to see where, so you don't keep going. Just picks it up a little bit better. Okay. Let's see. This is 19. Let's try some more. More of the complicated ones. This is 19 on the sheet, so you probably don't want to write a few of this down. Excuse me. Copy is right there. Good looking. I found it. So you have sine cosine over 1 minus sine squared. What is? Correct. So you recognize right away that you have 1 minus sine squared. So you start there, you see that, you're like, oh, that's cosine squared. So I rewrite it right away. So you have sine cosine over cosine squared.
Cosine, when the top cosine go away, sine over cosine.
Correct.
And that's tangent.
No. And you get?
Tangent.
Okay. All right, take that information and see if you can figure out 20 then. Take that same perspective and see if you can figure out what you get with 20. You should start to notice they're kind of the same a lot of times.
deleting it, you end up with.
What's 1 minus cosine squared? Sine squared. So when I'm looking at 21, okay? When I'm looking at 21 now, you'll notice that there's no squared terms. I can't jump to a Pythagorean identity right away. So I see that I have a sine, a tangent, a secant, which means I should probably try to rewrite these things in terms of sines and cosines. Now, when I do that, I have 1 over cosine minus sine times sine over cosine. You okay with that?
Yeah.
What's sine times sine? Sine squared. Do these guys have a common denominator?
Yeah.
So I have 1 minus sine squared. Huh. Oh, look at that.
Oh my gosh, that is cosine.
Squared. Yeah. If I shouldn't give you that much better. So you wind up then, yes, sir. I don't, because they have the common denominator. When you have this is the same thing as. Okay. All right.
Yeah.
22 is easy because what's cotangent squared plus 1? Cosecant. Cosecant is the reciprocal of what? What's cosine over sine? So you get cotangent squared. All right. Okay. What in the world do you do now? It is a trig identity, you're right.
You do the fraction before
You're right, but if you look at it, you get cosine squared over 1 minus sine minus 1.
Wait, can you just leave it? Wouldn't it be cosine squared over?
Why? Whoa.
You can't. No, there's no parentheses. No.
There's no parentheses. But you're kind of on the right track, though. Is 1 a perfect square?
Oh my gosh. Yeah.
Is sine squared a perfect square? Is that a subtraction symbol? Back to the numerator. You wind up with 1 minus sine, 1 plus sine, all over 1 minus sine, minus 1. Now can I simplify out? Now I can simplify out those terms because I can put parentheses around this and call it a term. And I have 1 plus sine now, minus 1, otherwise known as sine. Okay. If all else fails, see if you can factor it. Gee, I wonder what I'm going to do with 24 now.
It's probably nothing. Same thing, but there's the E and a C.
Yeah.
We're going to do basically the same thing here. Factor, because this is a difference of squares. So I have a secant minus 1, secant plus 1 over secant, plus 1 plus 1. And then secant, excuse me, I almost said secant squared. Secant minus 1 plus 1 is? Again, we secant destroyed that. It's bad. 50. 'Hello again. So I have cosecant over cosecant minus 1 plus cosecant over cosecant plus 1. And I need to make this look like 2 secant squareds.
Basically what you do. You just multiply the amount.
Okay, all right, good. So you're right. First thing I do is get the common denominator. So if I do a common denominator, it's going to be cosecant minus 1 and a cosecant plus 1. We okay with that?
Yes.
All right. Fraction on the left needs cosecant plus 1. So I have cosecant times the quantity, cosecant plus 1. Fraction on the right needs the cosecant minus 1. So you have cosecant times cosecant minus 1. Distribute, take care of your stuff in the numerator, and then take care of the denominator. The denominator, we created a difference of squares. You ready to see that? So the denominator you're going to wind up with then is cosecant squared minus 1. Numerator, I have cosecant squared plus cosecant squared minus cosecant. So far, so good?
Yes.
All right. So then that gives me, excuse me, the singular cosecants go away. And I wind up with 2 cosecant squared over cosecant squared minus 1. Not quite there yet. All right. So what is cosecant squared minus 1? Cotangent squared. Okay. So now you rewrite again as cotangent squared. Let me bring this over here. So I have 2 all right. This is when I like to split apart my fractions. Rick, you look worse. Okay. Is it? Are you guys okay if I rewrite cosecant squared real quick as 1 over sine squared?
That is totally fine.
The reason why I did that is because as soon as I recognized that I rewrote cotangent squared from the denominator as tangent squared in the numerator, I know that I'll have sine squared, cosine squared, and this might be very helpful. It is. It's still there.
I was just wondering.
Yeah. Yep. Still 2 over sine squared, then times sine squared over cosine squared. Huh. Wow.
Wow.
I was just saying, it's not even 8:20 in the morning. You guys are like,
This is American. This is what happened. We have.
Yes.
What's up? That's kind of when you're simplifying, yes. The verified part tells you what it's supposed to look like when you're done. This was a verified, that's what it was supposed to look like. Yep. Trying to think of any other little crazy ones I can show you that's a trick.
Yeah.
No, you don't have to do 58.
What about 57?
So, I'll tell you right now, you won't have to do one like 58, but we will do ones like 57. This is 57. And this is kind of the setup as we get more comfortable with this of some of the things that'll happen when we get to start solving equations. So when we start to solve equations with this stuff, we can only solve for them with one singular trig function, one trig function at a time. In this case here, you'll notice there's two trig functions. So what you normally try to do is you're going to use a trig identity to rewrite the highest degree, usually the squared term, in terms of the non-squared term. Because I can't rewrite cosine in terms of sine because it's not a Pythagorean identity, but I can rewrite sine squared in terms of cosine squared. Does that make sense?
Yeah.
So that's usually the trig that we wind up with. So I know that sine squared is 1 minus cosine squared plus 2 cosine minus 1. And again, 1 minus cosine squared plus 3 cosine minus 3. So here, I wind up just, I have to rewrite, yes ma'am? Cannot simplify over addition. Okay. So here you wind up with trying to rewrite some stuff, okay? I have, in the numerator, I wind up with just negative cosine squared plus 2 cosine. Because the 1's drop out. You okay with that? All right. Denominator, I have negative cosine squared plus 3 cosine minus 2. Just by moving stuff around. So far, so good? Could you have done that if this was could I just do this all willy-nilly?
No, absolutely not.
Same thing. No, it's addition. It's not a monomial. This is still factorable. So in order to factor this stuff, what we have to do is multiply everything by negative 1. Get rid of the negative. Basically, you're adding everything to the other side. Okay? So we do this correctly, we get, what would that be? Cosine squared minus 2 cosine over cosine squared minus 3 cosine plus 2. You okay with that? Okay. Now I got to factor.
Are we going to factor?
Yes, ma'am. Because you factor it exactly the same way as you would anything else. Treat cosine as x. What's x squared minus 2x? How do you factor that? GCF. You take an x out. So if you take an x out, you wind up with the same idea. Take out a cosine. You have cosine minus 2. Okay. What times what's positive 2? You add together to get negative 3. Negative 2 and 1, isn't it? So we get cosine minus 2. Well, that's convenient. Oh, sorry, it's minus 1. Thank you. Now I have terms in which I can simplify.
Okay, now
Now I can, no. Yes. Now I have terms. Now I'm here. So far, so good? Okay. So,
it's a verify.
was this a verify?
Yeah, it's one of you have to verify
So that means,
Oh, that's.
let's see what we'd have to do then. Let's see. Trying to think, if I multiply it by conjugate, that would get me cosine squared minus 1. So if they're trying to go to a secant, is it 1? I wonder if they do this. Oh yeah. They're turning it into a complex fraction. Okay? What they're doing is they're trying to turn it into a complex fraction by rewriting everything in terms of secants. Sorry to offend you, Mr. Feeney. It's kind of okay. Alright? So treat this like you would before. Common denominator is a secant. You get 1 minus secant over 1 over secant. Okay? So keep. Flip it. Oh, well, that's just rather convenient, isn't it? Oh. You guys are all like, son of a biscuit, yes. Peter's like, oh no. So let's see, on this one then, you should be able to finish out the rest of the simplify and verifies. Was that 39 through 56-ish? Yeah, don't worry about 58. There's a whole lot of other identities that are going on that we don't worry about. You'll do the root stuff and pre-calc. Like I said, I gotta let them teach you something. Okay. So work through 39 through 56. We'll go through those tomorrow, and then we'll get into the last little bit of it, and then we'll still be able to start equations then on Thursday without so much of a hassle. Okay.